Hi, it's Alexa, and today we're going to be talking about my final project, analyzing trends in the NWSL, which stands for the National Women's Soccer League. I chose to do for my project a data analysis tutorial where I take you through step by step of how you would import the data, clean the data, and do a few visualizations and linear and statistic tests on it. So the libraries that I use for my data are ReadXL, Dippler, ggplot, Plotly, Psych, Patchwork, CAR, and tidyr. All of these are described in the final project, but not fully described in this presentation. Our first step is obviously to import the data. And to do this, I had an Excel sheet with my data in it where each year of the 5 years that were presented, each year was a different sheet. So to do this, we used ReadXL using the ReadXL file or ReadXL command. And then we read each sheet in separately. Because this data was gotten from a website, it's not perfectly formatted, which is why we needed to use na.omit to remove any missing data. And then we could use mutate to add a new column, a year column, that would add the year for each sheet. So we could later use bind rows to combine all 5 data tables into one cumulative table. This is the code to support that. So as we can see, I have my ReadXL command where I am reading the NWSL player data Excel file. And this is the sheet for 2023. I'm omitting any missing, and then I'm adding the 2023 year column. Finally, I use bind rows to combine all 5 sheets and create a all data variable. This is one visualization that we can use. This uses ggplot, GroupMe, and a few calculations to show average goals by year and total goals by year. This also uses Patchwork to be able to use the facet and compare them side by side. So we can see that although the average goals by year it seems to be decreasing, the total goals by year seems to be increasing. And we look into that a little bit more of why that's happening in the final write-up. Next, we created an interactive box plot. So this is a quick preview of what that interactive box plot looks like. And this includes the distribution of goals scored by a player. So as you can see, the largest is 19 goals scored across each year. And then the data points are displayed with jitter to see the depth in the data. We can easily see the outliers as they're pictured near the top. And then the interactive features allow the user to explore the data dynamically. So as we can see, here's an outlier. One player scored 19 goals in a single season. And then as we scroll down, we can see the jitter working here where it appears wider because of that jitter that's been added. And it shows more depth and there's more data points located here, as if we hadn't used jitter, it would just be a straight line. And we can also see the quartiles. So we have our max, min, and then our median, which as we can see is 0. So why is it 0? That's because this data set includes a lot of players who either are on the team and don't play or play positions where they don't score. So many of the players are in a position where they have 0 goals scored. Next, I wanted to look into how we would make a linear regression for this data. So our first step in that is making a scatterplot matrix, which shows histograms and then regression lines between the variables and a Pearson correlation coefficient. So this is what our matrix looks like. On this right-hand side, this right triangle, we can see all of the correlation coefficients. And on this left-hand side, we can see all of the relationships between the values using a scatter plot. And this middle line that's kind of hard to see has the histograms and each variable. So how this works is that if we looked here and we looked here, we would go here. The correlation is 40.47, and then we could pull it here, and this would be the aligning graph. This can help us see where we might have problems with multicollinearity for our linear regression. Now we can do our linear regression. So to do our linear regression, we are going to use the CAR package, and this we list our dependent variable, which is goals scored in this case, and then all of the predictor variables that we want to use. and then we call the linear regression model. Once we have that model, we can use summary to find to find if the regression is significant and which values and variables are significant predictors, and as well as how they affect the end result and how they affect the dependent variable. Note down here we used VIF. What is VIF? VIF tells us how much multicollinearity we have in our data. So VIF shows returns a value for each variable, each predictor, that shows how much multicollinearity that variable has with other variables. So ideally, we want all our VIFs to be below 5. This data set has a large amount of multicollinearity, which I go through further in the full write-up. But just for this, one of the VIFs returned is over 100. Obviously, what we want to do with that variable is take the variable out, see if our data is still significant, see if our regression is still significant, and calculate the VIFs again. And then we keep working down. So why this R product? I grew up playing soccer. I played for 15 years, and I just found that found that analyzing data from the National Women's Soccer League was a natural choice for me, as I always wanted to play when I was younger. This project reflects both my passion for soccer and data analysis, allowing me to combine them meaningfully and share that with other people. The data set is very straightforward. Almost all of the data is continuous. There's very little missing data. And if there was missing data, I removed it at the beginning with no problem, and it allows for ideal data wrangling, visualization, and statistical analysis. Some key takeaways for the project is how to handle real-world sports data, the power of libraries like Psych, ggplot, and Plotly, and how fans and analysts can get insight from their data. Thank you for going through this project with me. All of the code as well as the HTML file all the code in the HTML file and as well as all of the data is located at my OSF page. Thank you.